Hi, and welcome to another Learn DeFi video. Today, I would like to talk about the types in Solidity. We will cover booleans and integers, addresses, fixed size arrays, strings and much more. Let's start with booleans. Just as in any other language, boolean can be either true or false. To create a boolean variable in Solidity, you first declare the variable type, in this case it is bool, and a variable name. Just like that. I also added two functions that we will discuss in another video. For now, I use them to show a common practice to use functions to change the variable value, and also to retrieve it. As you see, I did not initialize the variable. What Solidity does, is that it automatically assigns a value of false. We can display it by clicking on the function name. For now, the value is false. Let's now click on the other function that switches the value and display it again. As you can see, now it's true. There are two types of integers: signed and unsigned. Signed integers can contain negative numbers, unsigned integers contain only numbers greater than, or equal to 0. We can limit the size of the number by providing the size in bits when declaring the variable. For example, int 8 says that we will be working with signed integer that is 8 bits in length. Since it is signed, it can have a value from -128 to a +127. In case of unsigned integer of bit length 8, the value is from 0 to 255. In case you want to assign a larger number, you need to adjust the bit length accordingly. If you do not pay attention to this, the variable can overflow, or underflow, meaning it does not have the space to store the number, and an error will appear. Notice, we set the signed integer to 255. A value that is way too high. As you can see, we got an error. It is also good to note that by convention, the bit size should be powers of 2. So 8, 16, 32, 64, 128 and 256. If you do not assign the bit size, the compiler will automatically use the length of 256. Now let's discuss address. There are two versions of this type. First one is just address, and contains the 20-byte value representing an Ethereum address. The address payable means a wallet that can accept the Ethereum. It is not the same because just as we saw before, when we create a code, we then have to deploy it on the chain to be able to use it. It gets its own Ethereum address, however it is unable to accept Ethereum per se. The payable keyword therefore ensures you are sending Ethereum to an address that can accept it. It also has two additional members: transfer and balance. Now we will cover bytes and strings. Here, bytes are a fixed size arrays containing a sequence of characters. We can declare its length from 1 to 32, just as we did with integers. In this case we use bytes 1 to save a character, but we can store more based on the space we declare. However, it is important to be careful because just as with integers, we can make it overflow. Here, we declare byte 7 but we want to store 8 characters. As you can see, we got an error saying that the literal is larger than the type. Strings work just as in any other language. It is a dynamic array storing a sequence of characters of your required length. Arrays in Solidity are collections of elements of the same type. We can have static arrays with predefined length, or dynamic arrays where we can use push method to append more elements. Declaration of the array is as follows. We state the type we want to use, then we use square brackets and name the variable. I will use two functions, first one to add some elements to the array, and the second to change the first element of the array. Let's see how it works. We first have to add elements to the array by clicking Add Elements. I will add 0, -1, and 15. If we display it, we can see the elements. If we decide to change the first one, we can use the second function. Insert a value, 32, and display the array. Now the first element is 32. When we talk about structs, we can imagine it to be sort of a template. It has some similar aspects to regular classes. We can create an employee struct that has its attributes such as ID and name, we can assign it a department and see whether he or she is in the probation period. We can also instantiate the struct by creating a variable of this type. We can have an employee emp1 and employee emp2 that have the same type, employee, but different attributes. We create an instance of the struct by declaring the type. Here we can see that the type is employee since we will be inheriting the format that is declared in the employee struct. We then name the variable, in this case emp1, and state it is a new instance of the employee struct. Then we fill the information defined in the struct. Next type I will mention is enum. This can be imagined as a pick list of possible values that can be used. Declaration is straightforward, we just write enum, name it, and we put the required values to the curly braces immediately after the name. We can try to access some values. Note that we get an unsigned integer as a return value. We may create a variable containing one of the enum values. When we use the method to access it, we receive number 2, which is the index within the enum. Mapping in Solidity is similar to a hash table or a dictionary in other programming language. It is used to store the data in the key value pairs. Key can be any built-in data type and a value can be of any type. The syntax is following. We first declare the type, mapping in this case. Next we set the type of key and a value, and name the mapping. We will discuss the mapping in following videos as this type is widely used in Solidity programming. Thank you for watching and see you in the next video.